trying to show that the additive inverse of A times the additive inverse of B is equal to A times B. And for this, I'm going to eventually use the thing that we've already proved before, which is this. If you really want to see that we have proved it before, you can look and see this. So, okay. So to do this, I'm going to try to remind myself what A times this thing is equal to 0 by definition of the additive inverse of A. Similarly, this thing is equal to 0, so writing this is really equal to 0 times 0. We previously saw that 0 times anything is equal to 0. And now what I can do is I can use the distributive law here. So A plus negative A times the first thing, I can distribute that through here. This is foiling, except really it's just the distributive law a whole bunch of times. Okay, now I can use the distributive law again to go there and there. So we get AB plus negative AB plus distributive law there and there. A times negative B plus negative A negative B equals 0. And you might see why I chose to multiply these two things together. Why did I do this? Because I don't really know what negative A and negative B tells me except for these two things. If I multiply them together, I end up with negative A times negative B multiplied together. Well, this thing, I know that that's equal to negative AB. So AB plus, I'm going to replace this with negative AB. I'm going to replace this one also with negative AB. Negative A, negative B, still equal to 0. This, by definition, is equal to 0. Equals 0. And what I'm going to do is I'm going to add AB to both sides. By the way, that 0 is just going to drop out because 0 plus anything equals itself. I can add AB to both sides, but now this thing is equal to 0. Negative A, negative B is equal to AB plus 0. That's just AB. So I get negative A, negative B is equal to AB, in fact. So we are done. End of